Hello everyone! Today we will create an OpenGL program that displays fireworks, and it can be modified live as shown in the last video. While we are building it, the program will keep running all the time, and we will build it step by step, almost from scratch. Here you see the seamless examples directory, which you can download from GitHub, and the first thing we do is to copy a few files. I'm gonna create a directory, fireworks demo, and copy fireworks, start files, everything to fireworks demo, and that's all. And now we have here a directory with the files we need, and I'm gonna start a new IPython notebook. So we start with a bit of boilerplate to import seamless. We create a seamless magic for this in the new version of seamless. So let's create some points to be drawn on screen. So in OpenGL you need to have all your points within range of -1 and 1 for both x and y, unless you want to do some transformation on them. So let's create points, three-dimensional points, even though we will in principle only use x and y. Let's call them values, and we generate them using NumPy with a normal distribution centered around 0 and with a standard deviation of 0.2. And since it's OpenGL, you normally want them as floats and not as Python doubles. No, not as Python floats, which are actually doubles. So let's put them on screen as quickly as possible, and the quickest way to do that is to display them as an image. For this we can discretize those points onto a NumPy array that would represent an image. So let's do this manually. Create an image of 640 by 480. So for the x values, which are between -1 and 1 or a bit more, this will bring them in between 0 and 640, and this to maximize them completely and as integers, and the same for y. And then we set all pixels of the image where there's at least a point, should set them to 1 with this. So this creates a NumPy array im, but if you have a normal NumPy array, you have the origin in the lower left and x goes to the right and y goes up. This is also how OpenGL sees it. But images are not like that. They go, the data in an image goes line by line by line by line. So the origin is actually the upper left, and the first dimension is y and not x, because the x is the fast dimension, the second dimension. So what we need to do is to rotate our image like that, and then we need to store things in cells. Both the values should be stored in a cell containing a NumPy array, and since we're going to send them to OpenGL, we should have also a GPU OpenGL representation of that, and Seamless uses that as setStoreGL. This will make it available to OpenGL as a vertex buffer. And for im, well, we're not gonna send it to OpenGL, so it's just a array cell. And now I have a dirty piece of code lying around to visualize an image NumPy array using PyQt. I'm not go into detail, I'm just gonna copy paste it like that. And now I have to do ctx.im connect to ctx.display numpy.array. But we have to set the value of im, of course. There. And now we see a NumPy array appear, which every normally distributed dot, as you can see it's centered in the middle, every dot is red, and everything where every pixel where there's no dot, it's blue. Now let's add a bar in the lower right to mark one of the corners to make sure that we get the image correctly. And I re-discretize the values and then reconnect, and now we see here a bar appear in the lower right. Now you see it stretched in the x direction, which is the way it was defined. So here you see y goes from -7 to -8, which is indeed in the lower right, and x is stretched from 0.3 to 0.7. So in this way we check that at least as an image all of our points are correctly visualized. Now let's render these points using OpenGL. We're going to give vertex data to an OpenGL program that will essentially visualize them in the same way as we just did. And this takes a bit of work to set up. Which Seamless has a low-level wrapper around an OpenGL command called glprogram, and that's what we're going to use. So from the Seamless library, you're going to import glprogram like that. So glprogram is a macro like reactor and transformer. So it takes as inputs a JSON parameter dict, but it can also take a cell containing JSON code. And in Seamless, JSON and season, they are related. So we're going to define a season cell that contains the parameters for our GL program. We're going to continuously modify it. So the parameters, we call them ctx.program. And let's link them to a file called program.season. So now when we look here, we have now an empty file called program.season. Let's rename this. Okay, so we have an empty file program.season. So let's do it like that. And now we gonna create the GL program itself. So we call it GL program. It is a GL program. We're taking this season cell as a parameter, and another parameter is the window title, because it will create an OpenGL window. It will be called Seamless Fireworks Demo, and as a shorthand we'll call it B. Oh, something went wrong. Yes, because our program season file is empty, so we need to fill that up first. So what does GL program expect? Oh, you see it here already. It expects something called arrays. So that's the list of vertex arrays that will be provided to the program. So there we have only one of them, which is called vertex data. Other ones we don't need, but you could give multiple ones if you would like. And then in addition, you need a list of uniforms. So uniforms are OpenGL shader variables that do not change per vertex or per pixel, per fragment. Right now we don't use any. And then finally you need a render command description. And the render again needs several things. What it needs is a list of attributes that will be provided to the shader, vertex attributes. We will use only one called value, and we need to declare the data type. So it's a GLSL, OpenGL shader language Fact3 type, and it comes from the vertex array vertex data, so that needs to be declared. Seamless knows where to get it from, and that's it for the attributes. Then you need the command. This can be points or triangles or lines. We're going to draw points here, and you need the GL state. So what we're going to do here is, since here the background color is essentially blue, we're going to set the background color, it's called clear color in OpenGL. Let's set it to blue, blue like that. So save it, and you need to do something like this. There is no more error message, and more so, it's here now a black screen called Seamless Fireworks Demo, and you look at the status of P. There are unconnected things. This one is harmless, this should disappear in the next version of Seamless, but there is now an input pin called array vertex data. Since we declared here a array called vertex data, there will be now an input pin called array underscore vertex data, and this is where we should send our vertex data array. You can use P as a shorthand. So that's one. So this one's gone. Then we need to set uniforms, even though we're not gonna use them for now. So we get the uniforms, so we get an associated cell, and we set it to something empty, like that. And then we need to connect the shaders. So in case you don't know much about OpenGL, a shader is a little bit of GLSL code. It is very similar to C, and this is executed for every vertex, so every point that we give to the program. So this we call the vertex shader, and then after that it is the vertex defines one or more pixels, which are called fragments in OpenGL, and for every pixel the fragment shader is evaluated. So let's define them. So as far as Seamless is concerned, vertex shaders and fragment shaders are their own kind of subset, like a dialect of text. Well, they are text and they are code. So let's define them and link them to two files, vert shader and frag shader. But you should connect them also. Like that, so they're now connected to the program, and now the OpenGL complains that the shaders are empty, so it cannot do anything. So we have to define our shaders. Now I am definitely not an OpenGL expert, so forgive me for any kind of code that is ugly or doesn't follow the conventions, but fortunately the shaders are very simple, especially at this stage. So here you see now these empty files that have appeared. So for the vertex shader, I'm going to declare the GLSL version. 130 is enough. So we have a vertex attribute. So this is Seamless defines that for us. So we call it value. Then we need to find a main function. And what the primary thing that a vertex shader has to do is to define a variable called GL position. So the X, Y, Z actually come from value. And it has one more left, which is called W. We can set it to 1.0. So that's one. And then we also have the fragment shader, which is also very simple. It has to set the color well, let's look at the first one first. Then again, you have a main function, and it has to set a called GL frag color, describing the color of the pixel. And well, let's just make all of the pixels red, like they are in the image. So that's 1.00 and non-transparent, like that. And now you see that the picture looks exactly like the image as we displayed it. So they are identical. Here you see some little clouds of points. For example, over here is or this structure over here, and you see it's exactly the same. So we got everything correct and the same correct orientation also. So this was quite a bit of work. We typed like 50 lines of code without seeing anything change on screen. But remember that this is just Seamless version 0.1. It's not yet very convenient, but you can replace almost anything by a GUI at some point. So these things you could define in a GUI, the types and the file links and the connections. Just have to type the file names, of course. But also here the program.season, which has some attributes which may seem arbitrary to you. You could define them in a GUI. I mean, we can do something of that already. This was demonstrated in the a basic example tutorial. So if you would type this, so this again edits the ctx.program. So this will do create a cell that contains the text, and then this will create a cell. This will edit the cell that contains the source code of that. So as you see here, our things are there. Let's keep this one on top. So now if I change this to black, oh, so recreate the entire window. So okay, here it is. Yeah, we can change this to. I'm not sure what will happen if I do this. Oh yeah, this actually works. Let's undo that. So, well, this is again editing text, but the editor of this is here. So again, we can do rather trivial things such as changing the color or the font or things like that. But there's nothing that prevents you to create from here a kind of drop-down menu that says, well, do you want to render points or triangles or lines? And then instead of placing this text edit menu, to have all kinds of GUI elements associated with it. And in a later version of Seamless, you can also write HTML or so that does that. And you can do this, well, even while the program is running. So you could start your GL program OpenGL editor right here, well, and you can see the results right away. But for now, we gotta use what is there. GUIs are not yet there. So what we have is text, and we have to work with that. Now, up to now, we generated these points inside of the IPython console. Let's parameterize that so that we can regenerate the points as a function of settings. So we're going to do that in a transformer. So since a transformer is a macro, we can provide its parameters as a JSON cell, or more precisely as a season cell. So let's call them params gen vertex data, because we're going to create a transformer. This will generate the vertex data. So this will be its parameters. It's a season cell, and let's link it to a file which has the same file name, params gen vertex data.season. And now we have here the season file. The parameters should be quite straightforward. What we would want as an input pin is the number of data points you want to have. Let's call it n. It's a input pin. And what we want to generate, let's call it output, is the vertex data, which is an output pin, and the D type is a numpy array. So like that. So, and now we generate the transformer, create the transformer itself. Gen vertex data is transformer balance vertex. So we have the transformer. So let's create a cell containing the number of points. Set it to 10,000. And let's connect it to change vertex data. Should have a pin called N, and it does. And let's connect the output to the vertex data, which we defined already before. Now we still need to define the code of the transformer. So let's do it quick and easy, quick and dirty. So we generate the associated cell directly to cell gen vertex data.py. Animate complains that this cell is actually empty, so we should fill it with something. Well, we can almost copy paste the code we had before. Like here. Well, n should not be 1000, so we should assert that n is at least larger than 0. So n will be provided by Seamless. And then we just need to return values. If you would now eliminate this bar, for example, let's keep it on top. If everything is fine, now the bar should disappear. And it does. And the project gets, well, regenerated every time with a different random seed. So we have our points. Now let's then make them a bit bigger, because then it's easy to see. In OpenGL you can set the size of the points from your shader, but you have to enable it first. So let's go back to our program parameters, and then you have to enable vertex program point size, and this is the true. Now I did not design that. This is OpenGL. It had created that name, and it can be very verbose. Because GL state, well, the GL program, and in particular GL state, it's just a wrapper around OpenGL. So what really happens is that this is changed to all capitals, vertex program point size, and then GL is put in front, and then GL enable command is being executed. So there are lots of these constants, things you can enable and disable or set the value of, So you just have to look in the OpenGL manual, and then you essentially get a list of everything which you can put here in GL state. But yeah, the name of this variable is terrible. So again, please, you're very welcome to make a GUI that sets this kind of stuff in a more friendly way. So now we have enabled it. Once we have enabled it, we have to modify the vertex shader. So we've now a variable GL point size. Let's put this one on top again. Let's put it at 10. And now you see the points are much bigger. But it's not yet an explosion. To make this look more like fireworks, they should blend. They should be more light where there's a lot of points and more dark where there are fewer of them. So let's enable blending also. First we should go to the fragment shader and change the color from red into something else. So let's make it white. Let's add a bit of transparency. For now it's ignored because we have to enable also blending in OpenGL, which is done like this. We set blend is true, and then we define a blend function. Blend func, I believe. And you give two parameters. One of them should be src alpha, and the other should be called 1. Now you have additive blending. There, just like that. So now the values, the color values of every point is being added. And again, you could look in the OpenGL manual and define different blend functions to get different kind of visual effects. Now let's create a real explosion, which means that the position of the points is updated over time. Now we could do this on the CPU side to run the gen vertex data again and again, but it's better to do it on the GPU side. So we're gonna not gonna change any vertex data, but you're gonna send the time to the shader, and then the shader will dynamically compute the position of the point right before rendering it. And to do so, we should send time as a uniform to the shader, which means that we need to define uniforms. So the very first thing is just to create a cell that will contain our uniforms. It should be a JSON cell. And we should connect this cell to program uniforms. Just like that. And now we need to generate these uniforms dynamically. We're going to do that with a reactor. So again, we're going to define the parameters of the reactor as a JSON cell. And we're gonna link those parameters to a file. So there it is. Let's make it empty for now. And then we create a reactor called gen uniforms that uses those parameters. And a reactor has 3 code cells always. So let's create the start cell. We're gonna modify here. The update cell we're gonna leave empty for now. So an empty file is fine. and the stop cell we're not going to use at all. And essentially what it does, it modifies this uniform cell. So for that we should create an edit pin. It will read in the values but also write them out when you want that. Just like that. And now we can connect to ctx.gen uniforms like that. And let's close these things. And now we need to change the code cell, in particular the start cell. So let's call the uniform itself uTime. Let's just put it to 0. And so what we can do is then just return a dictionary containing the single item called uTime, but this is a reactor, not a transformer, so we have to explicitly do set. So now uTime should be defined. Let's check that. It is. So now we gonna send it into the shader. For that we have to modify our GL program. We're gonna now add a uniform. So the name must be uTime, and we have to declare a data type also, which is float. Again, the GLSL float. That's done. And now OpenGL complains that there's an unknown uniform uTime which is not being used. So that's fine, just let's use it. For that we go to the vertex shader. So you can declare the uniform here, float uTime, and so let's do nothing if uTime is 0, but if uTime is larger than 0 we're going to displace the values. Displace the position based on the time. So that, but only the XY. So let's do this. So we're gonna say XY is equal to the value that XY multiplied by uTime plus 1, and just keep set at 0. So again, as long as uTime is 0, nothing will happen. So we have here our frozen explosion still. But now if you go into the uniforms and change this, now you see something explode. So 1, 2, 3, 4, 5. If you would be using one of these fancy text editors like Lighttable or Atom's Helium plugin, you could invoke here some slider, you could see things happening in real time. It seemed as you could make uTime a cell, and then we could edit the cell and see the explosion happening in real time. But for now, just keep it simple, and let's cell gen uniforms modify uTime based on the system time. So for that we have to import time. Then we have to reorganize the code start function a bit. So let's define a function near explosion. Where you have a global start time, and we set it to the current time. And in the beginning we invoke new explosion. And then we have an update function, which is essentially what we did before. the due time is not 0, it is equal to time.time minus the start time, so the elapsed time since the last new explosion. And to make sure that this update function is triggered, we have to change also the code update. And we could do it unconditionally, but it's best to use a signal. So let's define a new input pin. So let's call it update, for example. So it means that you have to update. So the D type will be signal, so it doesn't contain any data. And the pin, it's an input pin, like that. And now here, if pins.update is updated, then we do update. Okay, it's a bit repetitive. So, but there's nothing connected to this pin. So when do we want to update the uniforms? Is right after the window has been drawn. Do we want to draw it again with a new value of the uniforms? So what we're gonna do is use another signal which is emitted by the GL program, which is p.painted. So every time, whenever this window is being drawn, the painted signal is emitted, and we're going to connect it to the update signal of the Gen uniforms reactor. And you have to kickstart this once. So you do p update .cell.touch, and after that, if you run the notebook, the connection will always happen. So let's define a new connection. Is this already on top? Yes, it is. So if you update the cell a bit, there we go. Oh, frame rate is not fantastic. And there again, a new explosion. And a new explosion. Whenever we change this code a little bit, this will be re-executed. And there it is. First part of exploding firework. Now let's make sure that these repeated explosions occur automatically. So let's define a period of how often they would occur. And let's say they would happen every 1.5 seconds. And then this we can connect to a seamless library construct called a timer, which is quite a simple thing. It's a macro that takes this period, and then you can connect it to a trigger. Oh, it has a trigger. Let's call it T. So this is again a signal which you can connect to anything you like. In this case, we would want to connect it to the uniform to reset. We don't have that yet. So let's define an additional signal on the generate uniforms. So not just to update, but also a reset. There we go. And then we can go resets. Okay. Ah yeah, so we have to of course connect it to the associated cell. There we go. This by itself does not do anything, but if we then modify the update function, so that if pins.reset.updated, we do a new explosion. And now we regularly have new explosions happening. As you can see, it really completely resets the explosion. The points are exactly the same. So we should also generate new vertex data. So it can be easily done. We add also a reset signal to the vertex data generator. Vertex data parameters are right here. We can copy paste it from the other one. Like this. Here. And set transformer, so that's all we have to do now is to connect to it, and it will be evaluated by itself. T.connect ctx.gem vertex data reset. There it is. And now in principle different ports will be generated every time. It's not so easy to see, so just set the number of points to something smaller. There. Yes, you see it all the time, they are different.